The fourth industrial revolution is upon us. This revolution is characterized by a fusion of technologies blurring the lines between the physical, digital, and biological spheres. At the heart of this transformation lies cyber-physical systems, or CPS. These systems are not mere technological advancements. They represent a fundamental shift in how we design, build, and operate industrial processes. CPS are more than just interconnected devices. They are integrated systems where physical processes and computational algorithms work in seamless harmony. This synergy allows for real-time data acquisition, analysis, and decision-making. Imagine a network of machines, robots, and sensors communicating and collaborating autonomously to optimize production. This is the power of CPS. The implications of this technology are far-reaching, touching every corner of the manufacturing industry. From automotive and aerospace to pharmaceuticals and energy, CPS is set to redefine efficiency, productivity, and innovation. The adoption of CPS is not just a trend, it is a necessity for industries to remain competitive in the rapidly evolving global landscape. As we stand at the cusp of this new era, it is crucial to understand the principles and applications of CPS. By embracing this transformative technology, we can unlock unprecedented possibilities and navigate the fourth industrial revolution with confidence. Cyber-physical systems are built on the foundational principle of integration. This means breaking down the traditional barriers between the physical components of a system, such as machines and robots, and the digital world of computation and data analysis. CPS achieve this through a network of sensors, actuators, and embedded systems. Sensors act as the eyes and ears of the system, continuously gathering data from the physical environment. This data is then fed into powerful algorithms that analyze and interpret it in real time. The insights gleaned from this analysis are used to control actuators, which are the muscles of the system, making adjustments to the physical processes. This tight-knit integration of physical and digital components allows for a level of responsiveness and adaptability never before seen in traditional manufacturing systems. CPS can react to changes in the environment, optimize processes on the fly, and even predict potential problems before they arise. This ability to self-regulate and adapt makes CPS a powerful tool for achieving efficiency and resilience in the face of ever-changing demands. The most compelling manifestation of CPS is in the creation of smart factories. These are manufacturing facilities where the entire production process is orchestrated by a sophisticated CPS. Imagine a factory where machines communicate with each other, robots work collaboratively, and production lines adjust themselves in real time based on fluctuating demand. This is the reality that CPS is bringing to life. Smart factories leverage CPS to achieve unprecedented levels of automation, flexibility, and efficiency. Machines are no longer isolated units, but are part of a highly interconnected ecosystem. They share information, coordinate tasks, and adapt to changing circumstances autonomously. This allows for streamlined production, reduced downtime, and optimized resource utilization. The benefits of smart factories extend beyond pure efficiency. CPS enables manufacturers to achieve greater customization and personalization in their products. Production lines can be easily reconfigured to accommodate different product variations, catering to the growing demand for personalized goods. This agility and responsiveness give manufacturers a significant competitive advantage in today's dynamic market.